Hi, welcome back to LeetCode. Today I'm going to discuss LeetCode problem 2583, Kth largest sum in a binary tree. So this video will contain first the problem statement, okay, then we will see some examples, then actually we will share the intuition, then actually we will share the C++ code, okay, with calculation of time complexity and space complexity. So what is the problem statement? Problem statement that you are given the root of a binary tree and a positive integer key. The level sum in the tree is the sum of the values of the node that are on the same level. Return the kth largest level sum in the tree, not necessarily distinct. If there are fewer than k levels in the tree, return -1. So first of all, they mention that we will given a binary tree. So what is binary tree? Binary tree is that any node will have maximum two child node, correct? It can be one, like for this it actually have two child node. Similarly for this it actually one. It may be possible that some node actually do not have any child, 0. Maximum two child are possible, two child, one child, here actually 0 child, okay. 0 to maximum child node can be present. So this is a binary tree. Binary means 2. That's why two child node can be present maximum. So it is clear why it is binary tree and a positive integer k. Now we would find the level sum in the tree. So suppose for this example one, the tree structure is 5, 8, 9, then 2, then 1, then 3, then 7, then 4, then 6, okay. So how many level are present here? This is actually level 1, or I can in short I can write actually as L1. Here actually I can write L2, here I can write L3, here actually it is L4. So in level 1, what actually nodes are present? Only 5. That's why the sum will also be 5. In level 2, how many nodes are present? 2 nodes, 8 plus 9. So sum will be 17. In level 3, how many nodes are present? 4 nodes. So the sum of level sum will be 2 plus 1 plus 3 plus 7. So the sum here actually is 2 plus again 3, 10, 10 plus 13. Correct? This is 13. And for this level 4, how many nodes are present? 2 nodes, 4 and 6. So the sum will be 4 plus 6, it will be 10 ultimately, okay. So here actually how many nodes are present? How many nodes not? How many levels are present? 4 levels. So 5, 17, 13, 10, okay. Now we will given a k. So you have to find the kth largest level sum. Kth largest level sum. So here actually maximum k will be allowed 1 to 4, okay. Allowed means if I try to find k is 100, if I want to know what is the 100th largest level sum, so here actually maximum 4 level are present. So for this case our answer will be -1. They mention that if there are less than k number, or if there are fewer than k levels in the tree, return -1, okay. Here you can check our k is actually 100, but maximum we have actually 4 level, so that's why I have to return -1, okay. Else suppose I want to know third largest level sum, then what will be third largest? Here actually if I sort this level sum, then the array will look like 5, 10, 13, 17. So if I reverse this, third largest, so first largest is 17, 13 is the second largest, 10 is the third largest, and 5 is the fourth largest, right? So easily I can return this index will 3, so easily I can return 10, so our answer will be 10, alright, for the k is equal to 3. Suppose I want to know first largest level sum, so then I will return the first index value. This is actually 17, correct. It is clear. Problem statement of the example, how it is going. how it's working, and we are getting the expected output. If it is clear till now, please like the video. Okay, and if you have any doubt, you can comment on that. Now problem statement and the example is clear. Now we will see the intuition. So we will give it any tree. This is suppose any tree. Okay, now we want to know the level sum, right? This is level 1, this is level 2, this is level 3. Now if we traverse the if we traverse the array or the tree in level wise, like first I will for this level 1 I will have the all the nodes present in this level 1. Okay, then easily I can actually calculate the sum. Okay, so sum 1. Then actually we will traverse or iterate, or actually we can do the operation for this level 2. All the nodes will have the level 2 present in the level 2. Then actually we will calculate the sum of this. Then actually we will get S2. Now I will go to the next level, level 3, and actually we will have these 2 nodes, and actually I will calculate the sum 3. Then what to do? We have to return the third largest or kth largest level sum value. So we will store in a vector all this sum S1, S2, S3. Okay, now we will sort this vector, okay, with decreasing order. Decreasing order, why? Because easily I can return k minus 1th index, that will be actually our kth largest. So this is actually other largest 1, largest 2, largest 3. Okay, so if k is equal to 1, first largest level sum value, then easily I can go to the return 0, 1 to index 0. So how actually get 1 minus 1 is equal to 0th. Simply for k is equal to 2, which index actually we have to return 1 index. So how actually can go to that index? 2 minus 1, that actually 1, first index, correct? It is clear how it is. So we'll traverse the, there actually I think you all have already solved this problem, that traverse a tree in level wise, correct? Level or traversal in a tree, correct? And here actually what is the extra actually we will do? We will check what is the sum of that extra. We will actually traverse that easily. Actually we have to traverse, this is correct. Extra we have to do, calculate the sum of that level wise, sum of that, and store in a vector. Okay, then ultimately after calculating all of this, after completion of the level of traversal, so we will have all the level wise sum in a vector. Then what we'll do, first of all we will do that if our this vector size, that I will store vector size is less than k, that means what? I actually have less than less number of levels, so return, that time return minus 1, correct? Else what I'll do, I will do vector size greater than equals to k, so that time return directly vector of k minus 1 index value, correct? This will actually return the kth largest level sum value. It is clear, right? Clear? Algorithm approach is clear. So first of all we have to do the level of traversal, then actually we will store the all the level sum in a vector, then actually we will sort that vector in the decreasing order. So first index will store the largest value, then second index will store the second largest. So whenever we check the the vector size is less than k, that time return minus 1. They have mentioned that. Else our vector size is greater than equals to k, that time directly return vector of index value of k minus 1. Okay, now how actually we can traverse the tree level wise. Now we will have the this, suppose this is actually tree, so this is actually a root, we will given this. Now Suppose in a queue, we've taken a queue, we'll store this 1, 2, 3, 4, 5. So suppose I have stored 1 initially, and first level will have only one node. It is always true, correct? So I will insert this. Okay, now actually what will check? You can actually, before iterating the next level or doing any operation, you can check in this queue actually have all the nodes present in the level 1. Correct? It is correct. In the level 1 actually only one node actually have, that is value is 1. Now actually we will see what is the size of this. Size of this actually is 1. One node actually present, that's the size of the queue also be 1. Now we will pop this node, and what I will do, I will see what is the child node of this. Child node is 2 and 3. So what I will do, I will take another queue. You can also, instead of this, you can actually use the same queue also. Suppose this is Q1, and in Q2 we are storing 2 and 3. Okay, and I have processed this. This node is processed 1. Now you can check our level 1 actually processed, and we will see what is the sum of this. Sum of we got actually is 1, and we have stored this into vector. Okay, that is storing all the level sum. I have stored 1. Now you can see this queue actually is containing all the nodes that is present in the level 2 and 3. You can check actually. Okay, now what to do? We will again process node 2. Okay, we will process the node 2. Is node 2 have any child node? Yes, it have actually. So I will store into this in another queue again. So the sum is currently is 2. Okay, I have processed this node 2, and I have stored all the child node of the node 2 currently. Now go to the next node. Next is 3. So node 3, what is the value? Is there any child node? No. So I will not insert anything in the Q3 or any another node, any another queue. And I have already processed this, and I will store the sum into the current sum. It is currently 5. Okay, now you can check our Q2 is empty. I have already processed all the nodes present in the level 2. Correct? I have processed this. Now what to do? I will store this 5 into this vector. Now I will go to the next level. Is there any queue present that is not empty? Yes, this Q3 is present, that is not empty. So what I will do? Again I will this is Q4. Now this is Q5. So in Q3, which node first I will see the first node is 4. Okay, so in sum 3 I will store 4, and I will check is there any child node for this node 4? No. So I will not insert anything, will not store anything in the Q4. Now I have already processed 4. Now go to the next node. So I will go to the sum. I will store the sum. Is there any child node for this node 5? No. So I will not store anything in the Q4, and I have already processed 5. Now you can check what is the level sum? 9. So I will store this into the vector. Correct? And you can check there is no child node present in the Q4. So I have already processed completion. I have actually completed the level's traversal of the tree. Correct? And I have stored, finally got this vector that is store the level sum. So now actually I will sort this. So after sorting, this will be our vector 951. Now whatever the kth value, I will check in this way. So it is clear how actually we are getting the level wise node into from the tree, and how actually Q actually data structure is helping us here. Now go to the actually code. So I have taken a queue that is storing the tree node pointer. Now name is Q, and initially I am storing the root into the queue. So that's a queue.push root node. And this vector I have taken vector long level sum. This is storing all the level sum value into this vector level sum. Okay. Now till our queue is not empty, I have to iterate. I have to traverse. Queue is not empty. That means what? That means what? That we have actually some node present in this level. Correct. Now we'll check what is the size of this. What is the queue size? Okay. And sum is initially 0 for this current level. Currently I am in level 1. for this string. So currently I actually have only 1 into the queue, and the size also will 1, and sum is initially 0. And while size is not size greater than 0, that means what actually till I actually have any node. So I'm actually popping the node from the front, okay, and I am storing what is the sum of that. So our sum will be currently sum plus 1, it will be 1, correct? Now I'll check, is there any node child node present in the left side or the right side, both left side and right side. If there is a child node present in the left side, I will store this into the queue. Okay, similarly if there is a right child node, so I'll store this, I'll store the right child node into the queue again. So our queue is currently have 2 and 3, correct? 1 actually I've already popped here actually 1 will be popped, correct? Now you can see that instead of, you can actually here actually for this intuition actually I have used 2 queue. One queue is for pointing to the current level, and next queue is storing the next level nodes. So instead of here actually I have used only 1 queue, because initially before starting the processing I have already checked what is the current size of it will indicate the what is the node present in the current level. So for the next level actually I will what will be the size will be 2, because 2 node represent 2 and 3. This is, you can check this actually ultimately level 2, node present in the level 2, correct? It is clear? And till our size is greater than 0, that means I will only pop 2 times for this current level. Okay, I have already found out that what is the number of nodes present in the current level. So that's why that many times actually I will run this while loop. And now this is a level sum. Level sum is the vector that is storing the sum, current level sum. So I'll store this into the level sum vector that push back the current sum. Okay, so I actually already store actually 1. Now go to the next time actually like queue actually have 2 and 2,3. 2 node 2 and 3, so size will be 2, and sum is initially 0, and our node will be 2, and it will be popped, and the sum value now it will be 2. 0 plus 2 it will be 2. And is there any left child for 2 node 2? No, there is no left right. So I'll go to the next size minus. So actually I have a node 3, so I'll pop 3 here. Q dot front I will get 3, it will be popped, and what will be sum? 2 plus 3, now it is sum is 5. Now is there a left child? Yes, so I'll store into the 4 here. And is there a right child? Yes, 5, so I'll store here. Okay, push means what? It will actually store into the from the end. That's why it's not creating any problem. Now again I'm storing the level sum. The current sum level sum value is actually 5. 2 plus 3 is 5, so I'm storing actually 5. Now again go to the next while. I'll check queue is empty or not. No, queue is not empty, because I have actually 2 nodes 4 and 5. So say again I will get the size 2, and sum is equal to 0. And what is the node actually I will get node 4, and the sum will be now 4. Current, is there any left child? No, for node 4 no. Any right child for node 4? No. So I will go to the next node is 5. So here actually I will pop 5, and the sum will be 4 plus 5. And is there any left child? No. Is there any right child for node 5? No. So I have completed this while loop iteration of the current level. Now I will store the current level sum into the level sum vector. So what I will store? I will store 9. It is clear? Now actually I have completed all the level wise iteration of the tree. Now I'll check whatever the number of level sum present in the level sum vector. So if your level sum vector size is less than k, that means what? Our number of levels is less than k. So I have written -1. I will return -1 from here. Else what I will do? I will sort the level sum vector in the reverse order. Reverse order means first I will store the 0. Reverse order means the decreasing order. First I will store the largest in this order. Okay, decreasing order. So then I will check I'll return the directly k minus 1 index value of the k minus 1. Okay, it is clear, because I have to return the kth largest. It is clear, right? See if any doubt, you can actually comment, and if it is clear for you, and if you like the explanation, please like the video. Okay, you can also comment that it is clear for you, like it motivates me. And if you not yet subscribe the channel, please subscribe the channel. Now come to the time complexity. What is the time complexity of this current algorithm? So you can check here. Actually, we are running a while loop. While loop actually run how many times? It will run actually ultimately number of nodes present in the tree, because each time actually I am actually iterating, right? Each node actually it will be visited only once, correct? Ultimately, so that time slot will be of n for this while loop. And here actually we actually have sorting this. So the sorting, normally what is the time slot? Time slot is big of k log k if k number are present, k levels are present. So to sort this array, average time slot will be k log k. Okay, so that's the time slot will be big of n plus k log k. It is clear. Now what is the space complexity? Space complexity, we have taken a vector of long that can size equivalent go to k. K means number of levels actually present in the tree. Okay, and any other thing, and we have taken a q, but this is actually temporary. It is clear? It is clear, right? Okay, thank you.